Hey guys, today we're going to be talking about black powder, its history and its uses, and we're even going to make some. So cue the intro music. So obviously, as a warning, do not attempt anything in this video. This is not an informational guide. I am an experienced individual and this is highly dangerous, so don't do it. Just for those who don't know, gunpowder is a mix of 3 chemicals: potassium nitrate, sulfur, and charcoal, or elemental carbon. Once combined, this mix burns rapidly, and if you refine all the elements, it can actually deflagrate, and when confined, it can even detonate. Shortly after its invention in 9th century China, they already wanted to use it in weapons. For our purposes though, since I don't have a ball mill, we'll be looking more at the slow side of things. So we're going to start by first purifying our potassium nitrate, which comes in the form of stump remover. And we're going to do this by recrystallizing it over water and heat. And we're going to add about 16 grams of it, and we're going to get about a 10 gram return. Then I dry it out after collecting it, and you can see it made this really nice needle crystal structure, which I dry out over some paper towels outside, and it dries pretty fast. Then I collect it in a bag and we let it dry out for even longer, just to increase the purity of our product. The next day, it's looking even better and more dried out. So we gather our other ingredients, which include charcoal, which I get in this weird artist's charcoal box, but it works. We get our sulfur through elemental purity, and S8, which is the molecular formula, and of course we have our stump remover. So we're going to take our recrystallized potassium nitrate and kind of crush it up. But we're also going to prepare a sample of uncrushed, unrecrystallized potassium nitrate. We're also going to crush our charcoal in a bag and take our sulfur and our potassium nitrate and combine those. Then, after we put all of our ingredients in a bag, we're going to start mixing it together and eventually form a nice, fully created compound. Now that we have our uncrystallized and recrystallized form of this gunpowder, we're going to take it outside and we're going to first burn the unrecrystallized one. As you can see, it took a while to start there, but once it started going, it produced a very large flame and left a huge amount of carbon residue and released a huge amount of gas into the air. As you can see, this carbon residue was quite disgusting, and it left a huge chunk of melted potassium nitrate. So next we're going to try our recrystallized structure, which is a lot more lighter, as you can see. This does burn, but it burns much slower, probably because it was extremely dense and not filtered at all, so all the particles were in huge clumps. As you can see, the residue left behind by our recrystallized structure is much smaller. The slow burning mix is better for modern fireworks. It might not look as impressive as the fast burning mix from our unrecrystallized structure. But if you were to take either of those mixes, and if you were to refine it, put it in a ball mill, and make sure it was a really granulated powder, it could actually deflagrate, as I mentioned earlier, and obviously you don't want to pack that into a tube and make it really tightly compressed and sealed off. That would be a bomb. And obviously most fireworks are not like this. Most fireworks are just a tube and a fuse sealed with a plasticizer. It is filled with pyrotechnic mixture that just releases sparks or fumes or or other kind of crackly instruments that are made from metals like magnesium and colored with metals like lithium or strontium. Overall, the history and chemistry of modern fireworks is very interesting. In this video, we were successful in demonstrating the mix's properties, its refining, and its potential dangers, even in modern fireworks like this one. Thanks for watching. Make sure to subscribe, and I'll see you guys later.